Hello and welcome to another one of D's ADD videos. Today we're going to be talking about LeChatliers Principle and his wonderful contribution to chemistry. So we're going to do it by looking at this example here. What if we did the following things to the following compounds? What would happen? So let's look at first N2, H2, and NH3. Okay. What happens if I increase N2? Which way does the equilibrium go? To the left or the right? Well, whenever I increase one of the reactants, what happens to the seesaw? Well, it would start to go down this way, right? So we would need to create more products and move to the right to get it to go back to equilibrium. Now let's look at a decrease. Let's do that in green. Which way would that need to go? Well, what would the seesaw do there? If I decrease it, it becomes lighter, and now we're going to be going that way, so we need to replenish the reactant side, so we need to go to the left. And that's for the decrease of N2. And this pretty much goes for the H2 as well, so I guess I might as well do that at the same time. Okay, and then after that, if we have a increase of the products, let's do that one. What happens there? Well, the seesaw in this case is gonna tip this way because it's getting heavier and heavier. So let's try that again. So this is original, and it gets too heavy on one side, it tips. So to get it back to equilibrium, we need to go now to the left. If I decrease it, the seesaw now becomes too light on the left side because we decrease. It's too light on the right side because we decreased the right side. So it's now going to look like that. That's not right. I'm sorry, it's 3 o'clock in the morning. I need to stop making videos. Alright, so this is the original scenario. If I decrease, okay, I drew my seesaw wrong. If I decrease the weight, it's too light on the product side, so it would go up on the lighter side, right, because of the lack of weight to balance it. So to move it back down, we need to go to the right. We need to add more weight that side. Sorry about that. I'm tired. Alright, so let's consider that this reaction has this delta H value. What does that negative 92 kilojoules mean? It means it's very, very exothermic, 92,000 joules, negative 92,000. Negative means we're looking at a potential energy diagram in which the reactants have more potential energy than the products here. So there's a delta H that's negative. Alright. So in a scenario like this, you can rewrite the equation like this by putting energy or heat on the right side. Okay? And now you can treat that as one of the products. So if I add another column over here, let me erase my seesaws, and I put energy actually, in the column over there in blue over here, I put temperature, so I'll stick with temperature. If I increase the temperature, what's going to happen? Well, I'm going to have more energy or heat. Let's change this to heat as well. I'm going to have more heat on this side, so it's going to tip the seesaw. If I increase that way, it's going to tip it like this, so then the reaction will need to go to the left to counteract that increase. It's like increasing one of the products because it's on the product side. Endothermic, the heat would be on the other side if it had a positive delta H, and you would treat the principle as if it was a reactant. So just like the N2s and H2s, it would behave. So what do you expect without even doing this next one? Well, it should behave just like this. If I decrease the temperature, it should behave just like this, reactant, right? And go to the right. Let's double check using the seesaw method. This is kind of spur of the moment invented thing, but it kind of makes sense. If I decrease the heat, then the right hand side gets lighter, so it goes up. So to balance it, we got to add more weight to the right side. So yeah, that was correct. All right. So that's basically it on those. I didn't do volume, did I? Let's do volume. I'm going to try to sneak volume in over here on the right hand side, or the left hand side of the table. So if I put volume, that's the thing we're changing, not compound or temperature. Let's say I increase the volume, or decrease. Let's look at decrease is the main one we really care about. When you decrease the volume, the rule was you go to the side that had the fewer moles. That way you have fewer molecules running around. Okay, so this left side had 3 plus 1 is 4. This side had 2, so it would drive it to the right. Okay, and that's mainly the one that would be reversed for the increase, but that's mainly the one you care about was the decrease. Let's consider this equation here. If we did the volume change, what would happen? Well, here I have 1 and 1, which is 2. Here I have 2. So there would be no change in equilibrium direction, or in the direction of the reaction to reach equilibrium. There would be no right or left movement. Alright? So those are some examples with concrete numbers and changes that you can just practice on your own. Watch this again. If it was at all too fast, pause it. Make sure you understand the concepts, okay? And practice, practice, practice. Thank you, and have a nice day.